we are now ready to do the last question, 2.4, where we are told that what we are asked actually, what is the acceleration of the system? Remember, the acceleration is of the whole system because it moves with the same acceleration. So what is the acceleration of the system when the 2 kilogram block is replaced by a block which is much larger than 3 kg? This question, the question that follows directly from multiple choice question will be question 2, and it will be more of a calculation question where we apply calculations on the topics that we covered in term 1. Before we can begin this question, as always, it is the culture, is that I'll write my 4 academic constitution rules, which is the I rule, the A rule, and the N rule. This rule allows me to solve any problem because it says I can. If I follow it, I can solve any problem. I is for interpretation, C is for classification, A is for answering the questions, and N is for navigating the answer that we have calculated or written down. I'll begin by interpreting the problem, and the first part of interpreting the problem is that we have to read the problem in order for us to go deep into it and interpret it. The question says to us that a block of mass 2 kg is connected to a 4 kg block by a light inextensible string. This is a very important statement because when they say it's light, it means that this string, we are going to ignore its mass. And also, because it is inextensible, it does not extend, it means the tension that is produced here is the same. We don't have different magnitudes of tension. Very important, this statement. Now, the question further goes to say a constant force of 30 Newton is applied. This is the force on the 4 kilogram block. It is applied on the 4 kilogram block. And the system begins to move. Very important, the system begins to move as shown in the diagram below. Now, when we apply this force, our system begins to move. And obviously, this would mean it will have an acceleration that goes in that direction. Just to write my data down, I'll come here and say we have M1 is equals to 2 kg. So I'm choosing this one to be M1. It is up to you how you choose them. And this will then have to be M2. The other thing that I'm going to do is actually choose direction. Now, one of the things that is on the instructions and information of a question paper is that always when you start a question, you start on a new page. You see here, I still have space, but I'm going to start on a new page. It's very important to do that, to follow that instruction. Now, my direction, I will choose it such that I will say anything that goes to the right should be positive, and anything that goes upwards should also be positive. By convention, this would mean that if I have anything that goes to the left, would be negative. The vectors here, I'm referring to vectors. And if I have vectors that go downwards, they will be negative. Now, after choosing direction, I think we can say here that the tension is the same, the acceleration also is the same when the system moves, because the fact that we have attached them by the same rope here would ensure that they move as a system, as one unit. Now, the question further goes to say the coefficient of kinetic friction between each block and the surface is 0.2. Now, here they also have given us, maybe if I could say quickly here, that they also have given us the coefficient of kinetic friction. Remember, they're saying here it's 0.2. Remember that this system is moving, so it experiences kinetic frictional force, and therefore it will have the coefficient of kinetic friction force. Remember, this is a property of the surface. And because these objects are moving on the same surface, they each experience the same coefficient of kinetic friction. Very important. So there's three things that are the same here. The coefficient of kinetic friction here on the surface, the tension that connects the two objects, and also the acceleration at which they move with. Even the velocity really of these objects is the same because they change that velocity at the same rate. Hence, we have the same acceleration. That is interpretation of the problem. Basically how we have read the theory and the laws that are part of that theory. Now, to classify this problem, I'll classify this problem as a problem that requires Newton's laws of motion, particularly F net is equals to ma. Those are the type of equations that I'm going to use, because this falls nicely into that where we study systems, objects that are connected with each other and that are accelerating. And also it requires the knowledge of vectors and forces, calculating the net force and all that. So that's how I'm going to classify this problem. Now, because I have a good background from interpreting the problem and also have ideas of where this problem falls, I am now ready to answer this problem. Can you see that these academic constitutions, these rules, they actually play a major role in assisting us to solve a problem. They allow us to solve any problem. I can solve this problem. Now, to answer this question, this problem, will go to the questions. Question 2.1 says to us that state Newton's second law of motion in weights. I mean, I expected this type of a question because I said this falls rightly into Newton's second laws of motion, and particularly F net is equals to ma. And that's the law that actually is relevant to this question. And we all know that that law says that the net force acting on an object is equal to the product of the mass and acceleration. That's what we said. F net is equals to ma. I will choose to go with this law because it's really relevant to this problem. However, there are other ways in which this law can be stated. One can state this law in a rather different way, where you say that when the net force acts on an object, it causes the object to accelerate. The acceleration of the object is directly proportional to the net force and inversely proportional to its mass. Another way of stating Newton's second law really is to say that the net force is the same as the rate of change of momentum, that is the momentum version. All of those statements or laws, when stated in that way, they will give you the 2 marks. I just happen to like stating this one so that it reminds me that I'm going to use it in this question when I solve problems. So that's the 2 marks there. The last thing that we do after answering a question is to navigate our answer. Navigation really means that we look at our answer and check if there's any errors and if we answered the question correctly. So this question here, it's a conceptual question. It's a question that uses concepts, right? We are not really calculating anything here. So here you just literally can reread the statement and check if there's any spelling errors, if your sentence is well written. You can quickly do that and check. Always just do that to confirm. Now, when we are done with navigation, we can then move to the next question to answer the next question. The question 2.2 says that draw a fully labeled free body diagram for the 4 kilogram object. Now, the 4 kilogram object is this one here. Remember that with a free body diagram, we model the object to be a dot and then we draw all the forces acting on it. I think the very first force that is clearly on the diagram is the force F, which is really on the diagram there, 30 Newton force. The second force that is evident and clear is the fact that the string will stretch and exert a tension force here. So there will be a force that we call tension force this side. I just want to draw my line straight because that is very important in terms of marking, right? Now, the other forces that will come to mind for me will be the force of gravity, because this object is on the Earth's surface, so there will be the force of gravity here. The Earth will exert a force on this object to try to pull it vertically downwards, and this force will be given by Fg, which we can say is equals to m2 times g. Remember, I called this object m2, so we can say it is m2 times g. That's the formula of it. And the other force that we're going to have here will be the force that the surface exerts on this object in the upward direction, and we call that the normal force. I'm going to so call this N2 to say that it is the force of M2, because we're saying this mass here is M2. And the other force that I think is here will be the frictional force, because remember, we are told here there's kinetic frictional force. It means the surface also exerts a frictional force, and the frictional force will oppose motion, will be a force that goes in that direction. So I'm going to draw this frictional force here so that it sits like that. Let's draw it properly. So we're going to have the frictional force here, and I'm going to call it Fk2, right? Remember, the frictional force on M2 will be different on M1, so we're going to call this Fk2 to say it's the frictional force on M2, because we labeled our mass as mass 2. Now, this question was for 5 marks. So normally with free body diagrams, if they say 5 marks, it means you have to have 5 arrows. And if you are able to identify 5 arrows on your diagram, that's part of navigation. You're basically checking if you have answered everything and you didn't make errors. The one thing that we can check is to confirm if the direction of your forces, are correct. If they're pointing in the correct direction, and you haven't done funny things where your normal force is sitting like that. It should be vertically straight. Your gravity should be vertically straight, and even these forces, unless they are at an angle, these ones, you just check all those things. Now the 5 marks will come from marking each arrow, then you get 5 marks. I always say these are free marks, because drawing something like this has never been difficult. Has really never been difficult. These are free marks, and I mean, at this stage you can see that if you answered these 2 correctly, you already have taken half of this question. Now, if we go to question 2.3, they say to us that calculate the magnitude, very important, magnitude. So that means we're not going to attach direction on our final answer. So 2.3.1, they want us to calculate the magnitude of the acceleration for the 2 kilogram block. Now, this question is a very funny question, because they're saying that we should find the acceleration for M1, right? And they make it seem as if M1 has its own acceleration that is different from M2. But that's not the case. We know that the acceleration of the 2 kilogram block is the same as the acceleration of the 4 kilogram block, and they have the acceleration a, so we're just going to write it as the acceleration a because it's the same. So basically, Calculating the acceleration of the 2 kilogram block also is calculating the acceleration of A. If we get the acceleration to be a 2 meters per second squared, it means also 4 is moving at that acceleration. So don't get confused by this type of phrasing these questions. Now, if you check this question here, it is actually 5 marks, right? So that means we're going to do a pretty involved calculations here. So we are on 2.3.1, 2.3.1. Now, when you solve these problems, we basically focus on each object individually. We look at the object of interest. I'll firstly start by looking at M1. So I'll say for M1, that means I'm looking at this object. If we quickly draw a free body diagram of M1, we will note that M1 has the tension T, and this tension is the same. So the tension that we have here is the same tension here. We also have the frictional force here, which is Fk1, right? Because I said these frictions are not the same. You know, the friction for M2 is not the same as the friction for M1, even though the coefficient of friction is the same. We also have the acceleration due to the force of gravity, which is Fg is equals to m1 times g. We also then have the normal force, and this normal force really is for the first object. I'll call it n1. That's why there we have n2. Now I'm going to do the net force in the y direction. In other words, the net force in this direction here. So the net force is the vector sum of all forces acting on the object. So I'm going to add or combine these forces here. Because we chose up as positive, it means our n1 will be positive, right? Remember, we said any vector that goes upward is positive and any vector that goes downward is negative. So our n here will be positive, but our mg, which is the force of gravity, will be negative. We'll have negative m1g. And we will say that this is equals to 0. Remember, what we are doing in the background here is that we're saying this net force is equals to mass times acceleration, right? That is the Newton's second law. But in the y direction, our blocks are not moving. This block, it is not going up, it is not going down as well. It is only moving in this direction. So it means the acceleration here, if we say the acceleration in the y is going to be 0, there is no acceleration. That's why here when we put 0, we get to this 0 here. Now we can clearly see that here the normal force will be equals to m1 mg, because I simply take this to this side since I have a 0 that side. Now with this information, I can then now look at the net force in the x direction, which will be given by the tension goes to the positive direction, because we said anything that goes to the right is actually positive. So I'll firstly have T, which is positive, and I'm going to subtract here Fk1. And this is equals to the mass of 1 times its acceleration. We said this acceleration, we'll call it A. Now to solve this, I am going to change my friction to its formula, which says mu k times normal force. So this means here I'm going to have T minus the mu k times normal force of 1. Remember, the coefficient of friction is the same. That's why I'm just writing here mu k. And this is equals to m1 times the acceleration. But we just said here that the normal force is actually the same as mg, right? m1g. So this means here I can come and say T minus mu K times M1 times G is equals to M1 times A. Now at this stage I can substitute values that I have. So for T I don't have, but here I have 0.2. Here I have 2 kg, and we know that the acceleration due to gravity is a constant number of 9.8. You can always get this on the information sheet. When you go to your last pages of the question paper, you'll be able to get this constant G. Here we have 2A because the mass is really 2. Now, from here you can press your calculator to determine the value here. So we are going to have 0.2 multiplied by the 2 multiplied by 9.8, and this gives me a value of T. It's actually a negative 3.92, and we're saying this is equals to 2A. Now you'll notice that I have two unknowns, right? That means I'm going to do simultaneous. I can then call this equation 1. I can call this equation 1. For me to get equation 2, it means I have to then consider this object as well individually. It will be my object of interest. So that means I'll say for M2, what we have is that we have the sum of forces in the y, and they're equal to 0. And we say our sum of forces here, when we look at our free body diagram, they are going to be N2 minus M2G. So we're going to have N2 minus M2G being equals to 0. And this means that N2 is indeed equals to M2G. Now I'm going to then say that my sum of forces in the x, the net force in the x, is equals to the mass times the acceleration. This is Newton's second law really. But we know that the net force can also be defined as the sum of forces acting on the object. And in this case, when I look at my free body diagram, I actually have F being positive here because it goes to the positive direction, and we subtract both the T and the F2 because they go in the negative direction. So I'm going to have minus T minus FK2 being equals to, remember this is M2A. Now from here I'm going to further change my friction to mu K times normal force of 2 is equals to M2A. But we know, we just said the normal force is actually equals to M2G. So this means here I'm going to have F minus T minus mu K, and here I have M2G is equals to M2A. Now when I'm at this point, I can substitute all my values, right? Remember, I'm doing all these steps just to show you in case you have forgotten, especially because we've done this in grade 11, just to refresh your mind. But you can really skip some of these steps here. So when we substitute, we know that our force F, we said it is 30. It is given by 30. Remember, we are pulling, where am I? We are pulling the M4 with 30 here, and we don't know the tension, and we know that the coefficient of friction is 0.2, and our mass is 4 kg, and G is a constant. Again, you can find this on your information sheet. Now the mass is 4, and then we have 4A there. Now again, this one requires a calculator. My like terms is 30 and all this. I'm going to combine this. So I'm going to say here 30 minus 0.2 times a 4 times 9.8. And this gives me a positive 22.16. So we're going to have negative T here. We are going to have a negative T plus 22.16 being equals to 4a, and then I can call this equation 2 because also I can see that I have two unknowns. Now when you look at these two equations, you can see that they are linear equations. I can simply just add them. I can simply just add these two equations. So I can say here that equation 1 plus equation 2, what do I get? Now I'm going to add each term here. I'm going to say t plus negative t. We all know that when you say t plus negative t, you'll end up with t minus t, and this will give you a 0. So the t and the t basically they cancel each other out. And here I have a negative 3.92 plus 22.16. Here we have a negative 3.92 plus 22.16. And this gives us a value of 18.24. So we're going to get here an 18.24. And this side I'm actually just having here 2a plus 4a. So we are having here 2a plus 4a. That should give me a 6a. So this is going to be equals to 6a. Now from here we can see that we can simply straightforward get our a, because I'm going to divide by 6 on both sides so that this cancels. Then I can have a is equals to our a would be 18.24 divided by 6, and we get an acceleration of 3.04 meters per second squared. And that is our final answer. And remember, they said we should calculate the magnitude, so I'm not going to put direction here or worry about direction. Now this question, when we look at the answer and try to navigate this answer, we can see that it makes sense because actually it came out positive. So it tells us that the system is accelerating in that direction. So that's very important, because if we got a negative answer, it means it was going in that direction. But according to how we have read the statement, the blocks actually accelerating or moving in that direction. The other thing there is to check if I have correct SI units and the symbols there, and everything looks good for me from that perspective. Another way in which we can actually really navigate this answer is to change parameters in our equations. So if I look at this equation here, or this one here, actually I can change the applied force, maybe increase it, and see how the acceleration will behave. Because I mean, if we increase this force, we expect this object to move faster, to have a bigger acceleration, stuff like that. You can look at things like that. You can also change the coefficient of friction and check how other parameters behave. So that's another way of navigating a problem. Now this problem, we're going to mark it out of 5 marks. So your 1 mark will firstly, the first mark that you're going to get would be setting up this equation and setting up equation 1. And the same is true here, setting up this equation and setting up equation 1. As I said, some of these steps you can really skip them in your test when you are fit on these problems. And so far we have 4 marks, and the last mark will come actually from your final answer if it's correct, and that's how you get all the 5 marks. Because we are done answering this question, we will then go to 2.3.2, where they say calculate the tension in the string. Now to calculate the tension in the string is not really a hassle. That's why even the question is only 2 marks, because really what we do here, we use one of our equations that we had there at the top to then solve for the acceleration. If I look at this equation and this equation, I think this one is much more easier to work with. I'll take this one. So I'll say here that t minus 3.92 is equals to 2 times A. And now to find the tension, I'm simply going to say it's equals to 2 times the 3.04. We're putting our acceleration here now, and we're going to have a plus 3.92 because this, when it goes this side, is going to be positive. Then from here, this question becomes really, really, really boring because we just use our calculator to find the final answer. 3.92. Then we get our tension force to indeed be equals to 10 newtons. And again, our answer came out to be positive. It means the tension that we have calculated here is the tension that is experienced by this 2 kg block because it's going in the positive direction. However, we are not interested in the direction because they said we should calculate the magnitude. So I'm just navigating my answer to see if it makes sense. So when it's negative, it means it is applied on the 2 kilogram block. But remember, the tension is the same. It means on the 4 kilogram block, we also experience the same tension, but it's going to be negative 10 Newton, right? So that is just navigation. And as I said, you can also navigate the answer by changing parameters in the equations. So on the above equations, when you change the applied force, you change the coefficient of friction, or maybe even change the masses, maybe you make this mass to be big or to be small. Even here, if you make this mass to be big or to be small, the acceleration will change, right? Because it's a variable that depends on those, it's a quantity that depends on those variables, so it will change as well. Now, when the acceleration has changed, it means also the tension would have changed as well. So you can play around quickly with your calculator to see that those changes align with what is expected. Does it make sense when you change those variables? If it doesn't make sense, it means this answer is wrong, and also this answer is wrong. Now, this is going to be marked out of 2 marks. They'll mark the fact that you substituted this and you wrote the final answer there. And that is how you get your 2 marks. Now, we are now ready to do the last question, 2.4, where we are told that what is the acceleration of the system? Remember, the acceleration is of the whole system because it moves with the same acceleration. So what is the acceleration of the system when the 2 kilogram block is replaced by a block which is much larger than 3 kg? This question, they further say to us that write only in decrease, remain the same, or increase. This question is a navigation question, is a question that assists us, is a question that actually applies the 4th rule in our academic constitution. So this question, the examiners, when they put it, they actually assisting us to see if our answers that we got here are correct and they make sense. That's why these questions are here, right? It's exactly what I was telling you to say. If you change a variable in these equations, the variables that we have is the force, is the coefficient of friction, is the mass. Even here we have the same variables, the tension, the coefficient of friction, the mass. If we change any of these variables, the acceleration will also change, but it must change in a certain expected way, right? So that's what is happening as well here. They are changing the mass now. So if we look at this diagram here, just to explain what I mean when I say they change it in an expected way. If we change this mass to be much larger than this mass, in other words, if we when they say much larger, I can say, for example, let's say we make this to be 10 kilogram. Do you see that 10 kilogram is much larger than 4 kilogram? What do you think will happen to the acceleration? What will be the acceleration? The system will move very slow. Our acceleration will be a vector that's like very small now because we are now pulling a much bigger object here as a system. So it won't move as fast as when we have a small 2 kilogram object. So our acceleration should decrease. However, we have to see this in our equations. It has to make sense. That's what I'm saying. The the changes that we make on these equations, they must make sense. They must be the expected result. So we expect here the acceleration to be smaller. But let's see if it will be smaller when we look at it from the equations. I have said that, let's say we use a 10 kg mass. So we're changing mass 1, which is this mass here. We're changing it to 10 kg. So it means on my equation, I'm going to look at this equation here. And actually, I'm changing this mass here now to 10 kg. Right? That would mean that I'm going to have t minus 0.2. I'm going to have a 2. No, not a 2 anymore. It's a 10 now. We have changed this to 10. Then I'm going to have a 9.8. And on this side, I'm going to have a 10a. Now, when we punch our calculator, we will have 0.2 times the 10 times the 9.8. And this will actually give me a t minus 19.6 to be equals to 10a. Now, it means on this equation, we don't have a, right? On this equation, we don't have a. It means now that I'm going to still add my equations. I'm going to add this equation with this new equation where we have 10. You can see that the t and the t, they still cancel each other here because this other t is negative. But now I have actually a negative 19 here. I have negative 19.6. And I'm actually adding that to 22. I'm adding that to 22.16, right? So the 22.16, it comes from the equation 2. And what I get now is actually a number that says 2.56. Then the other thing that we look at is the masses on this side. Is the 10 here. We have a 10a plus the 4 now, because remember the 4 kg mass hasn't changed. So we have a 10 plus the 4, which will give me a 14. So this means this side I'm going to have a 14a. Now when we divide both sides by the 14 here, we can see that this side it cancels. Now I have the new acceleration, which will be the 2.56 divided by the 10. And look at that, our acceleration is now 0.26 meters per second squared. Do you see that it has dropped significantly? Because when we had a 2 kilogram block, we got an acceleration of 3. And look at now, it is there at 0.2 when our mass is much larger, right? When our mass is much larger, right? And this makes sense because now it's difficult to pull a bigger object here. So if they move, they'll move at a very small velocity, acceleration, even velocity. But if it's small here, the acceleration will be much bigger. They'll move faster at 3 meters per second squared. So our answer here that we're going to choose will be decrease. We expect the acceleration to decrease. So this is question 2.4. 2.4, the answer will be the decrease. And this actually gives me confidence to say my answers that I calculated here, they actually are correct because I'm getting a consistent result here when I change variables on these equations. Had it been that when I do this calculation here, the acceleration actually increases and becomes 5 meters per second squared, which is bigger than what we got here, then it wouldn't make sense. It means my calculations are wrong because here on the physical situation, you can't make this bigger and the acceleration becomes bigger as well. It cannot be. I hope this question made sense to you and serves as a good revision for the upcoming exam.